Hey folks, today I am going to take on a challenge and try to explain the world of analytics in under half an hour. Now you might think it's a tall order, but it's a challenge I'm excited to accept. But what exactly is analytics? Simply put, analytics is the scientific process of discovering, interpreting, and communicating meaningful patterns in data. It's about turning raw data into insights for making better decisions and predicting potential outcomes. Analytics is the practice of analyzing this data to uncover patterns and insights. It can help us understand which demographic is buying the most, the best time to increase production, or how weather impacts our sales. But analytics isn't just about generating insights. It's also about interpreting and presenting those insights in a way that's easy to understand and act upon. This is where machine learning, ML, and artificial intelligence, AI, come into play. In the context of a business environment, machine learning is often used to optimize performance. For example, ML algorithms can analyze historical sales data to predict future demand, enabling businesses to manage their inventory more effectively. In this way, ML is a powerful tool that can enhance various aspects of business operations. On the other hand, you may have heard about generative AI. This form of AI is designed to create new content such as text, images, or music. For example, ChatGPT, developed by OpenAI, is a generative AI model that can write human-like text. These models are intriguing and have many exciting applications, but they are distinct from the analytics and machine learning tools commonly used in businesses to drive performance and decision-making. We'll delve into the intricacies of generative AI in a separate video. Overall, analytics, ML, and AI are key parts of the digital transformation, empowering businesses to be more proactive, make data-driven decisions, and remain competitive in a data-rich world. Why is it so important? Think about a company like Walmart, selling millions of products globally. How do they decide how many products to produce? Let's call their hypothetical products widgets. Which color of widgets sell the most? When do widgets sell the most? Which regions prefer which type of widgets? To answer these complex questions and make strategic decisions, Walmart turns to analytics. Traditional analysis might give you basic information like total sales or the best-selling widget color. But analytics goes much deeper. It uncovers patterns, relationships, and trends, allowing companies like Walmart to predict future sales, optimize production, and ultimately enhance their profitability. According to a study by Forbes Insights and Dun & Bradstreet, nearly half, 49% of companies say analytics help them make more informed business decisions, and a report by McKinsey suggested that the effective use of big data and analytics could add $13 trillion to the global economy by 2030. Types of data in analytics. Now that we know what analytics is and its importance, let's talk about the types of data we work with. Broadly, we can classify data into three categories: structured, unstructured, and semi-structured. Structured data is organized in a manner that computers can understand and process. In our Walmart example, structured data could be sales records with clear fields like widget color, quantity sold, date of sale, and location. Unstructured data, as the name suggests, lacks a predefined format. It's a bit like a wild horse, full of potential but hard to harness. Customer reviews of widgets, social media posts about widgets, and emails concerning widgets. These all fall under unstructured data. Finally, we have semi-structured data, which is a mix of the above two. It's not as organized as structured data, but does contain tags to separate elements. An example could be widget data in XML format. Examples could be data around how customers are interacting within social media platforms, clicks, impressions, and more. Understanding these data types helps us know what we're dealing with and how to approach its analysis. Data sourcing and wrangling. With our data types defined, it's time to talk about where this data comes from and how we prepare it for analysis. This is known as data sourcing and wrangling. Data sourcing is all about gathering the necessary data for our analysis. For Walmart, data can be sourced from internal systems like sales databases and business intelligence tools, or external sources like social media or market research. Once we have the data, it's rarely in a perfect state for analysis. This is where data wrangling comes in. We may need to clean the data, handle missing values, convert data types, or even combine multiple data sources. For instance, we might merge sales data with customer demographic data for deeper insights. Remember, garbage in, garbage out. The quality of our data wrangling will directly impact the quality of our analytic results. Descriptive analytics. Let's dive into the first level of analytics, descriptive analytics. Think of descriptive analytics as the rear-view mirror of a car. It tells you what has happened in the past. In terms of our retail widget example, descriptive analytics could tell us how many widgets were sold, which was the most popular color, and when the sales peaks occurred. Retailers will often focus on equivalent time periods like the same week last year, or same month or quarter, often called comps. Walmart might use descriptive analytics to understand the overall sales performance of widgets. It answers questions like, what was the total sales last quarter? Or, what was the most popular widget color during the holiday season? This level of analysis provides a solid foundation to understand the basics before we start exploring why things happened and what will happen in the future. Diagnostic analytics. Moving on to the next level, we have diagnostic analytics. Diagnostic analytics is like a detective. It tries to find the reason behind what has happened. It digs deeper into data to understand the cause of a particular outcome. For example, if the descriptive analytics showed us that the sales of green widgets suddenly spiked last month, diagnostic analytics will help Walmart figure out why that happened. Was there a successful marketing campaign, or maybe a celebrity endorsement? By finding these patterns and correlations, diagnostic analytics helps businesses get to the root cause of outcomes. Data visualization. Having understood what happened and why, it's crucial to be able to communicate these insights effectively. This is where data visualization comes into play. Data visualization is the graphical representation of information. It uses charts, graphs, and maps to help users understand patterns, trends, and insights in the data. Take our Walmart example. A simple bar graph could visually represent the sales of different colored widgets over the past year, immediately highlighting trends and anomalies. Or a heat map could be used to represent the density of widget sales across different geographical locations. Visual analytics has been shown to help users find insights up to 28% faster than traditional methods, according to a study by Aberdeen Group. This is driving a widespread shift from traditional BI tools to visual analytics tools like Power BI and Tableau. Tools like Tableau, Power BI, and even Excel provide a range of capabilities for creating effective data visualizations. Remember, the goal of data visualization is not just to make pretty pictures, but to reveal the story that the data is trying to tell us. Predictive analytics. Having a good understanding of the past is useful, but what if we could predict the future? Enter predictive analytics. Predictive analytics uses statistical techniques and machine learning algorithms to estimate future outcomes based on historical data. For Walmart, predictive analytics could estimate how many widgets they are likely to sell in the next quarter, or predict which new widget colors might become popular. These predictions can be extremely valuable in planning inventory, adjusting marketing strategies, and making other key business decisions. Machine learning basics. So we've mentioned machine learning a couple of times, but what is it exactly? In simple terms, machine learning is a type of artificial intelligence that enables computers to learn from data without being explicitly programmed. Machine learning is a subset of artificial intelligence, AI. It's the practice of using algorithms to parse data, learn from it, and then make a prediction or decision without being explicitly programmed to do so. In the field of analytics, machine learning can automate complex analytical model building. The more data the model is trained on, the better it can predict. In fact, companies like Walmart use machine learning extensively to optimize almost every aspect of their operations, from sales forecasts and customer segmentation to fraud detection and personalized marketing. Database querying with SQL. Now, all these forms of analytics require one common thing: data. But where does this data come from? How do we extract the relevant pieces of information from vast databases? This is where SQL, or structured query language, comes into play. SQL is a standard language for managing and manipulating databases. In a retail scenario, Walmart likely has databases filled with sales data, customer data, and inventory data. SQL allows analysts to write queries to extract the specific data they need for their analyses. For instance, an analyst might write a SQL query to pull all the widget sales transactions for the last quarter to feed into a predictive analytics model. Knowing SQL is an essential skill in the field of analytics because it allows you to interact directly with databases and extract the data you need in a flexible, efficient manner. Advanced analytics techniques. As we dive deeper into analytics, we encounter more sophisticated techniques like segmentation and classification. Segmentation involves dividing your market into distinct categories based on similar characteristics. For instance, Walmart might segment their widget buyers based on age, location, or buying behavior. This can help tailor marketing strategies to different groups. Classification, on the other hand, is about predicting the category or class of an item or event. Using previous data on widget sales, a classification model could predict whether a new widget will be a hit or a miss. Both these techniques enable a more nuanced understanding of the business landscape and aid in decision-making. Regression analysis is a powerful statistical method that allows us to examine the relationship between two or more variables of interest. When applied to business analytics, for example, in the retail industry, it can help identify which factors matter most, which can be ignored, and how these factors interact with each other. Let's say we're interested in determining what factors most impact the sales of our widgets at Walmart. Potential factors could include pricing, store location, marketing spend, or even weather conditions. By using regression analysis, we can assign a weight or coefficient to each of these factors. The larger the coefficient, the larger the impact of that factor on sales. For instance, if pricing has a large positive coefficient, it means that sales are significantly driven by the price of our widgets. Perhaps a price decrease leads to an increase in sales volume. On the other hand, if marketing spend has a small or negative coefficient, it might mean that increasing our marketing budget doesn't necessarily lead to higher sales, or could even be counterproductive. Thus, regression analysis helps us make informed business decisions by pinpointing the most important drivers of our results. Ethics in data and analytics. Analytics holds immense power, but with power comes responsibility. As we gather and analyze data, we must be mindful of ethical considerations. This includes respecting privacy, ensuring accuracy, and avoiding biases. For instance, while analyzing customer data, we must comply with data protection regulations and ensure the data is used in a manner that respects customer privacy. Implementation and validation of models. Once we've built our analytical models, we need to validate them to ensure they're reliable and accurate. This involves using a portion of our data to test the model's predictions and fine-tuning it as necessary. After validation, we can implement the model in a real-world business context, like predicting next quarter's widget sales for Walmart. But remember, models should be regularly reviewed and updated as new data becomes available. This is often called ML Ops. Real-time analytics. In today's fast-paced business environment, real-time analytics is becoming increasingly crucial. This refers to the use of data and related resources as soon as the data enters the system. For Walmart, real-time analytics might help monitor widget sales and inventory levels in real time, allowing for immediate adjustments and decision-making. Importance of communication in analytics. Lastly, none of these insights are useful if they can't be effectively communicated to stakeholders. Good analysts don't just crunch numbers, they tell stories with data. Data storytelling is pivotal in driving decision-making, as it combines data, visuals, and narrative to make analytical results accessible and meaningful to all stakeholders. A well-crafted data story allows decision-makers to grasp insights intuitively and act upon them effectively. That wraps up our whirlwind tour of analytics in under 30 minutes. Remember, this is just the tip of the iceberg. There's a lot more to explore and learn in the world of data and analytics. Please like and subscribe to this channel to continue to accelerate your knowledge together with modern AI.